So now let's focus on the diagrams so that whenever you encounter such kind of diagrams, you can see or understand which one is an endothermic and then which one is an exothermic reaction. So now let's start with this one. So looking at this diagram, the first diagram, so now I've shown you in terms of R stands for the reactants and then P stands for the product. So R stands for the reactants, P stands for the product. Remember that change in heat, we're talking about the energy, right? So now let's remember that we spoke about endothermic and exothermic. We said that an endothermic is when the energy is taken in from the surrounding, right? And then exothermic is when the energy is taken out to the surrounding. So now let's understand this. Let's look at the heat. Let's say here we have 0. Let's say here we have 0 is to 0, right? So as we are having 0 is to 0, when we count from here going up, we are doing what? We are increasing. So now what we should understand about change in heat. Change in heat is represented by change in enthalpy is equal to the heat of the product must always subtract the heat of the reactants. This is the general formula when we calculate enthalpy or heat. So what we understand is that if the product, the energy of the product is greater than the energy of the reactants, your heat is going to be positive. This means that the presentation of this diagram is an endothermic reaction. The energy is being absorbed inside. The energy is being absorbed. The energy is being absorbed into the reaction, right? And then now moving along to exothermic. And exothermic, we see it by the products are below the reactants. Remember, on the endothermic, we are saying that the products are higher than the reactants. But in exothermic, we are saying that the products are lower than the reactants. So as the products are lower than the reactants, we are saying that the energy is being taken out, is being released. The energy is being released from the reaction to the surrounding objects. So this one also works in terms of the heat is equal to the heat of the product must always subtract the heat of the reactants. When we say that, if here I have 10 and then here I have 20, I'm going to say 10 minus 20 is going to give me a negative answer. When it gives me the negative answer, the negative is always less than 0. Then this means that the reaction here is an exothermic reaction. And then remember that when you see H, when you are given that change in H equal to negative answer, remember that is an exothermic. And then when you are given that change in H is a positive answer, remember that it is an endothermic. It means the energy is being absorbed, here the energy is being released. But remember that the reverse, this I shown you by reversible reaction. Remember that the reverse of endothermic is exothermic. The reverse of exothermic is endothermic. What I mean by that, if I go forward, is an endothermic. But if I were to come back, it will be exothermic. Why? It's because the product are less than the reactant. Remember here also, now we are going to say that if I move forward is an exo, but if I were to come back, it's going to be endothermic. So this interpretation is very simple in terms of when you were given questions to calculate, or when you're given statements to identify which one is an endothermic and which one is an exothermic. But remember, exothermic is when the energy is being released to the surrounding, right? For example, heaters, fire, everything that you can feel pressure from them in terms of heat. And then endothermic is when the energy is being absorbed into them. Or we can say that the energy is being removed from the surroundings. Right, so this is the interpretation of the graphs in terms of what is an endothermic and what is an exothermic. But remember, in this ones, we have what we call activation energy, and then we have what we call activated complex. So activation energy, it's when we talk about the energy required or the minimum energy for reaction to take place, right? So activation energy is when you talk about the energy, minimum energy that is required to start this particular reaction.